Hi, hola, bonjour, and Salaam. Welcome to Blueprint Bazaar. In Part 18 of our plastic shredder machine full assembly walkthrough, we take a detailed and practical step toward physical realism by adding ISO standard screws and bolts to the mounting and side plates using SolidWorks built-in design library. Up until now, we've focused heavily on structural elements, shafts, blades, gears, and bearings, but none of those components would function properly without being securely fastened in place. That's where mechanical fasteners come in, and today's episode is all about introducing those critical hardware elements into the design. We begin by navigating to the SolidWorks Toolbox and Design Library, where standardized hardware is available for direct use. These components are designed according to real-world ISO standards, which means they are not only dimensionally accurate, but also ready for manufacturing references and BOM generation. From this library, we drag and drop hex bolts, cap screws, and machine screws into the assembly. Each fastener is selected based on shaft clearance, thread length, and head diameter to match the holes we've already designed in earlier parts of the assembly. The placement of these bolts and screws is not random. Every fastener must align with the pre-cut holes in the mounting brackets and side plates. Using concentric mates, we align each bolt's cylindrical shaft with the hole it's intended for. Then, we apply coincident mates between the bolt head and the outer face of the plate to seat it flush. This guarantees not only visual alignment, but mechanical realism, ensuring no bolt is floating or penetrating incorrectly through geometry. We pay close attention to ensuring that these fasteners don't interfere with other internal components. One by one, we inspect clearances around the gears, bearings, and rotating blades. This is a crucial step in real-world engineering, where even a few millimeters of intrusion can cause mechanical failure or increase wear. Fasteners that sit too deep can clash with internal parts, while those placed too shallow may not provide proper strength. This part also showcases how SolidWorks simplifies hardware management through its SmartMate inference. By dragging fasteners into position near compatible holes, SolidWorks automatically suggests mates, speeding up the process and reducing errors. This kind of intelligent automation becomes invaluable when placing dozens of bolts across a large assembly. Beyond mechanical function, the addition of fasteners enhances the visual integrity of the model. The shredder begins to look less like a conceptual structure and more like an engineered product, something ready for fabrication, with physical fastenings that make sense in the real world. As we wrap up this part, the shredder now reflects not only its functional purpose, but also its assembly method. Every hole is now filled with the hardware it was designed to accept, closing the loop between digital design and physical construction. Please keep supporting us as we dive deeper into mechanical design and development. Don't forget to like, share, and subscribe so you never miss a step on this engineering journey with Blueprint Bazaar.